All right, those of you watching this at a later date, we are now working on page 7 of the lecture guide for section 5.3. And I see again that I have a typo. There is no trigonometric function that goes CCS. This actually should say right here CSC for cosecant. Yeah, and that didn't work so well. So right here, this should say CSC for cosecant. And so in general, what we're going to do when we're trying to graph a secant or cosecant function, we're going to graph the associated sine or cosine function. So for y equals a times the secant of bx plus c plus d, we're going to start by graphing y equals a times the cosine of bx plus c. And for y equals a times the cosecant of bx plus c plus d, we'll start by graphing y equals a times the sine of bx plus c. So since we're trying to graph f of x is equal to negative 2 cosecant of x plus pi over 4, we'll start by graphing y equals negative 2 times, and we're trying to do cosecant, so we'll do times the sine of x plus pi over 4. Okay. And so I'm going to go ahead and do that real quick down at the bottom. Let's see. So I remember that sine x goes through the point 0, 0. So I'm going to go ahead and put a dot at 0, 0. And the amplitude is the absolute value of A. So in this case, the amplitude is going to be equal to 2. Okay. And what else do I need to remind myself about? Well, the period in general is 2 pi over b. And in this case, b is just 1, so the period is equal to 2 pi. Now, we do have a phase shift on this one. So we're going to shift negative c over b, which means we're going to shift it negative pi over 4 divided by 1, which is still pi over 4. So that point that I put down a second ago at 0, 0, I'm going to cross that out. And it's actually going to be at pi over 4, 0. Make sense so far? Okay. And then normally, we would have a point at pi over 2, 1, or in this case, pi over 2, 2, because the amplitudes change. That's going to be shifted to the left, pi over 4 units, so it'll be right here. And then normally we'd have a point at pi 0 that again gets shifted to the left, pi over 4 units, so that one goes there. And then normally we'd have a point at 3 pi over 2, 0, and that gets shifted to the, well, not 0, sorry, 3 pi over 2, negative 1, or because the amplitude has changed, negative 2, again, we shift it to the left, 2 pi over 4 places. And then again, we would normally have a point at 2 pi 0, it gets shifted to the left, pi over 4. So this is one period of my sine graph. I'm going to go ahead and do the best I can to make a nice smooth curve. Whoa, that's not a very smooth curve. There we go. And I'll go ahead and draw in another period of my graph. Okay, so this is my graph of y equals, this is my graph of y equals negative, oh my goodness, did we forget to do the negative part? I think we did. So this is my graph of y equals 2 times the sine of x plus pi over 4. We actually need the graph of y equals negative 2. So I'm going to do that in a different color. And to do that, I'm just going to flip my graph upside down. That look okay so far? Okay, next we're going to make the vertical asymptotes. And the vertical asymptotes correspond to the points where the y value is equal to 0. Okay, and so I'm going to choose another color for that. I think I'll do purple. Okay, and then we're going to draw the U-shapes between the asymptotes. Oops, I used the wrong one. So that should be on my previous graph, the black one, after I flipped it. And I'll go ahead and label that. My purple graph is y equals negative 2 cosecant of x plus pi over 4. All right, did anybody have any questions about any of that? Okay, I'm going to stop the recording.